Alright, so in this tutorial what we're going to be doing is we're going to be using the analog to digital converter on the KL25Z. And how we're going to do this is what we're going to pretty much do is we're going to read in a variable set voltage, and we're going to go ahead and read that in to the microcontroller. And how we're going to know if it's actually detected the change is we're going to make it so we're going to use a digital to analog converter and output that respective voltage that it picked up. Now note that there's the analog to digital converter on the KL25Z is 16-bit, and the digital to analog converter is 12-bit. Well, we're not going to care about that too much because what the program is going to pretty much do is it's going to get that voltage value converted to 16 bits, and then when we're going to assign it to the digital to analog converter, it's going to round off to and shave off a few voltages so that it'll fit in the 12-bit range that the digital to analog converter works in. So we're not going to be worrying again too much about how to actually change all that sort of stuff. And so let's go ahead and get started. Okay, so we're going to go ahead and wire up the the analog to digital converter and the digital to analog converter setup. So what this is going to require is an electronic component called a potentiometer. And so the idea behind this is that it's effectively a variable resistor. And what you pretty much do is you can put one of these pins, one of the either leftmost or the rightmost pin as a 0 volts, and the other pin as like a higher voltage. So we're going to use 3.3 volts. And the pin in the middle is going to give you a variable voltage between 0 and 3.3 volts. And the way that you can set it is by rotating this knob right here. So you can go ahead and rotate this knob. And so we're going to use this to create our variable voltage that's going to be read in by the analog to digital converter. So we're going to go ahead and put this down onto the breadboard. Alright, so with that we need to supply it 3.3 volts and 0 volts. So let's go ahead and locate 3.3 volts on the board. So that is right over here. So 3.3 volts is right here, and 0 volts is right over here. So it's actually, second pin down from the bottom is 0 volts. So we're going to go ahead and connect that to one of the side of the rightmost or the leftmost side. So we're going to go ahead and connect that to the rightmost side in my case. And then we're going to go ahead and connect 3.3 volts to the other side. That's the 5th pin. And actually, it might be better if we actually connect this to the ground line, and then connect this to the actual potentiometer itself. So we're going to be using the ground pin for another reason as well. So once we have that, we're going to go ahead and grab another pin. We're just going to use connect the digital analog converter to the middle pin of the potentiometer, which is where the variable voltage is going to be set at. So PTC1 is actually this pin right here. So we're going to go ahead and put a wire in here and connect this to the middle pin of the potentiometer. With this in mind, you also want to connect the ground voltage to the other side of the potentiometer as well. So we're going to go ahead and do that. Okay, so that sets up the potentiometer and the analog to digital converter. So all we need to do now is connect the digital to analog converter to something that we want to manipulate or just see what the voltage output is. Just for the sake of this, we're going to go ahead and just connect it to an LED. So we're going to go ahead and grab another wire, connect the digital to analog converter to some part of the board, which we're then going to connect to an LED. So we're going to go ahead and just arbitrarily select a point that we're going to put in the breadboard. So we're going to put it over here. And with that, we're going to go ahead and grab an LED, and we're going to go ahead and make it so that the longer tipped pin is going to be connected to the digital analog converter, and the shorter tipped pin is going to be connected to ground. So we're going to go ahead and do that. Okay, so that pretty much sets up our circuit. Just to have another overview of this as well. The idea is we have an analog to digital converter, which is connected to a potentiometer, and the potentiometer is going to output a variable voltage that we're going to set by rotating the knob, and then that signal is going to be interpreted by the microcontroller, which is then going to be outputted by the digital analog converter. And we'll see that as we have a lower voltage, the LED is going to get dimmer, and as we increase the voltage, the LED is going to get brighter. So I'm going to go ahead and run that test. So we're going to go ahead and hit a new program. Again, I like to just use the one of the templates already. I'm going to call this the ADC to DAC test. So that's the analog to digital converter to digital to analog converter test. Go ahead and open that up. All right, go ahead and main C++, and let's go ahead and open this up. We're going to go ahead again, delete the inner guts that we don't want. So we're going to be left with a blank program for us to fill up ourselves. So we're first going to use first assign the analog out class that we previously learned in the previous tutorial about the digital to analog converter. I'm going to call this DAC, and again, the KL29Z has PTE30 as the digital to analog converter. Now we're going to be using this new function, this new class called analog in, and you're going to go ahead and call this a value, something called whatever you want to call it. I'm going to call it ADC, and you're going to go ahead and assign it a pin that works as an analog to digital converter. We're going to go ahead and just arbitrarily pick PTC1 as the analog to digital converter. So with that, we're going to go ahead and fill the guts here. So what we want to first do is we first want to read in a voltage value, and then we want to spit out that voltage value. So voltage value to the DAC, and read in a voltage value from the ADC. And so the way that the ADC works is it works pretty much like a digital in, where you can go ahead and read out whatever it is, but instead of having it being either 0 or 1 or true or false, the way that this works is that it's going to give out a float value from 0 to 1, where 0 is the lowest voltage, so 0 volts, and 1 is the maximum voltage, so 3.3 volts. So it's going to be, you can go ahead and just arbitrarily assign something like, the example would be a float analog value equal to ADC, and then ADC can be from 0 to 1, where 0 means 0 volts and 1 means 3.3 volts. And again, the idea is like if you get 0.5, that pretty much means it's 1.65 volts, and et cetera, et cetera. So what we're going to pretty much do now is we're going to go ahead and create a variable called float that's going to store the value on the analog to digital converter. So again, it's going to be analog value, and we're going to say it equals to ADC. So it's going to head, and this while loop, it's going to go ahead and read the analog to digital converter value, and it's going to store it into the variable analog value. All right, so the next thing we're going to go ahead and do is we're going to use the digital analog converter, and we'll go ahead and assign that analog value. So what we're pretty much doing effectively is we're reading in an analog signal, storing it into a variable called analog value, and then we're going to assign that analog value to the digital to analog converter. So it's going to, so pretty much what's going to happen is that the microcontroller is going to spit out the voltage that it read in. So we're going to go ahead and compile this, and we're going to go ahead and upload this onto the microcontroller, and we're going to go ahead and play around with it. Oops, one typo. Haha, my bad. Didn't see that, but it's not analog in, it's analog in. I'll go ahead and recompile. Alright, so I have it all set up, and as you can see, the LED is actually flickering. So the reason why it's flickering is that the analog to digital converter is slightly a little bit noisy. So it's actually, the flickering noise is actually, you can actually see it from with the LED, and it's also associated with the potentiometer itself. So the potentiometer won't actually give you a perfectly set voltage. It's actually going to fluctuate a little bit here and there, because the idea of a potentiometer is it's two resistors, so it's a resistive divider, and so the resistance is going to actually slightly fluctuate a little bit, which is going to cause the voltage fluctuation as well. We're going to go ahead and just rotate the potentiometer using a screwdriver, and you can see that as I rotate in one direction, it gets dimmer, and as I rotate in the other direction, it's going to get brighter. Go ahead and rotate a bit more. There we go. And so there's actually like a small range in this potentiometer where you can actually see it slightly dim and actually decrease and have that sort of flicker. So, and if you go ahead in the other direction, it's going to go 0 volts. So that's how you use the analog to digital converter, and this is pretty much a fun little stuff you can play with to go ahead and just program it to use the analog to digital converter. So have fun.